Hi guys. Welcome to another video of Learning Hub. Hope you are all well. First thing first. If you are new to our channel, then you know what you have to do. Yes, subscribe to our channel Learning Hub and smash the like button. Also press the bell icon to get instant updates of new videos. Okay, so let's start today with Roblox Studio Gameplay Mechanics Hit Detection with Lasers. Use raycasting and hit detection to shoot lasers from a blaster. Part 1 Hit Detection with Lasers. In this course, you'll learn how to cast a laser from the blaster in creating player tools and detect whether or not it hits a player. Raycasting to find collisions. Raycasting creates an invisible ray from a start position towards a given direction with a defined length. If the ray collides with objects or terrain in its path, it will return information on the collision, such as the position and the object it collided with. Finding the mouse location. Before a laser can be shot, you must first know where the player is aiming. This can be found by raycasting from the player's 2D mouse location on the screen directly forwards from the camera into the game world. The ray will collide with whatever the player is aiming at with the mouse. Open the tool controller script inside the blaster tool from previous video creating player tools. If you haven't completed that course yet, you can download the blaster model and insert it into starter pack. I will post the link in description. How to add models. Models can be added into your inventory to be used between any game. In a browser, open the model page, click the Get button. This adds the model into your inventory. In Studio, go to the View tab and click on the Toolbox. In the Toolbox window, click on the Inventory button. Then, make sure the drop-down is on My Models. Select the blaster model to add it into the starter pack. At the top of the script, declare a constant named max_mouse_distance with a value of 1000. Create a function called getWorldMousePosition. Local max_mouse_distance equals 1000. Local function getWorldMousePosition. End. Use the getMouseLocation function of userInput service to get the player's 2D mouse location on the screen. Assign this to a variable named mouseLocation. Local userInput service equals game, getService userInput service. Local mouseLocation equals userInput service, getMouseLocation. Now the 2D mouse location is known, its X and Y properties can be used as parameters for the camera, viewport point-to-ray function, which creates a ray from the screen into the 3D game world. Use the X and Y properties of mouse location as arguments for the viewport point-to-ray function. Assign this to a variable named screen-to-world-ray. Local screen-to-world-ray equals workspace.currentCamera, viewport point-to-ray, mouseLocation.x, mouseLocation.y. It's time to use the raycast function to check if the ray hits an object. This requires a start position and direction vector. In this example, you will use the origin and direction properties of screen-to-world-ray. The length of the direction vector determines how far the ray will travel. The ray needs to be as long as the max_mouse_distance. So you'll have to multiply the direction vector by max_mouse_distance. Declare a variable named direction vector and assign it the value of screen-to-world-ray, direction multiplied by max_mouse_distance. Local direction vector equals screen-to-world-ray, direction *max_mouse_distance. Call the raycast function of workspace, passing the origin property of screen-to-world-ray as the first argument and direction vector as the second. Assign this to a variable named raycastResult. Local raycastResult equals workspace, raycast, screen-to-world-ray, origin, direction vector. Collision information. If the raycast operation finds an object hit by the ray, it will return a raycastResult, which contains information about the collision between the ray and object. Raycast result property and its description. Instance, the base part or terrain cell that the ray intersected. Position, where the intersection occurred, usually a point directly on the surface of a part or terrain. Material, the material at the collision point. Normal, the normal vector of the intersected face. This can be used to determine which way the face is pointing. The position property will be the position of the object that the mouse is hovering over. If the mouse isn't hovering over any object within a distance of max_mouse_distance, raycast result will be nil. Create an if statement to check whether raycast result exists. If raycast result has a value, return its position property. If raycast result is nil, then find the end of the raycast. Calculate the 3D position of the mouse by adding screen to world ray, origin and direction vector together. If raycast result, then return the 3D point of intersection. Return raycast result, position. Else, no object was hit, so calculate the position at the end of the ray. Return screen to world ray, origin plus direction vector. End. Part 2, firing towards the target. Now that the 3D mouse position is known, it can be used as a target position to fire a laser towards. A second ray can be cast between the player's weapon and the target position using the raycast function. Declare a constant called max_laser_distance at the top of the script and assign it to 500, or your chosen range for the laser blaster. Local max_laser_distance equals 500. Create a function called fireWeapon under the getWorldMousePosition function. Call getWorldMousePosition and assign the result to a variable named mousePosition. This will be the target position for raycast. Local function fireWeapon. Local mouse location equals getWorldMousePosition. End. This time, the direction vector for the raycast function will represent the direction from the player's tool position to the target location. Declare a variable named target direction and calculate the direction vector by subtracting the tool position from mouse location. Normalize the vector by using its unit property. This gives it a magnitude of 1, which makes it easy to multiply by a length later. Local target direction equals mouse location tool, handle, position, unit. Declare a variable named direction vector and assign to it the target direction multiplied by the max_laser_distance. Local direction vector equals target direction *max_laser_distance. A raycast params object can be used to store additional parameters for the raycast function. It will be used in your laser blaster to make sure the raycast doesn't accidentally collide with the player firing the weapon. Any parts included in the filter_to_sentence instances property of a raycast params object will be ignored in the raycast. Continue the fireWeapon function and declare a variable called weapon raycast params. Assign a new raycast params object to it. Create a table containing the player's local character and assign it to the weapon raycast params.filter_to_sentence instances property. Raycast from the player's tool handle position in a direction towards the direction vector. Remember to add weapon raycast params as an argument this time. Assign this to a variable named weapon raycast result. Local players equals game, get service players. Local weapon raycast params equals raycastparams.new. Weapon raycast params.filter_to_sentence instances equals the players.local player, character. Local weapon raycast result equals workspace, raycast, tool, handle, position, direction vector, weapon raycast params. Finally, you'll need to check that the raycast operation returned a value. If a value is returned, an object was hit by the ray and a laser can be created between the weapon and hit location. If nothing was returned, the final position needs to be calculated in order to create the laser. Declare an empty variable named hitPosition. Use an if statement to check whether weapon raycast result has a value. If an object was hit, assign weapon raycast result, position to hitPosition. Local hitPosition. If weapon raycast result, then hitPosition equals weapon raycast result, position. End. If weapon raycast result has no value, calculate the end position of the raycast by adding together the position of the tool handle with direction vector. Assign this to hit position. Else, calculate the end position based on maximum laser distance. Hit position equals tool, handle, position plus direction vector. Navigate to the tool activated function and call the fire weapon function so that the laser fires each time the tool is activated. Fire weapon. Checking the object hit. To find if the object hit by the laser is part of a player's character or just a piece of scenery, you'll need to look for a humanoid, as every character has one. First, you'll need to find the character model. If a part of the character was hit, you cannot assume the parent of the object hit would be the character. The laser could have hit a body part, an accessory, or a tool, all of which are located in different parts of the character's hierarchy. You can use Find First Ancestor of class to find a character model ancestor of the object hit by the laser, if one exists. If you find a model and it contains a humanoid, in most cases you can assume it's a character. If you have other models in the game that contain humanoids, further checks will be needed. Add the highlighted code below to the weapon raycast result if statement to check if a character was hit. Local character model equals weapon raycast result, instance, find first ancestor of class, model. If character model then local humanoid equals character model, find first child, humanoid. If humanoid then print, player hit. End. Now the laser blaster should print player hit to the output window every time the raycast operation hits another player. Testing with multiple players. 2 players are needed to test if the weapon raycast is finding other players, so you need to start local server. Select the Test tab in Studio. Make sure the Players drop-down is set to 2 players and click the Start button to start a local server with 2 clients. 3 windows will appear. The first window will be the local server, the other windows will be the clients for Player 1 and Player 2. On one client, test shooting the other player with the weapon by clicking on them. Player hit should be displayed in the output each time a player is shot. Part 3 Rendering the laser beam. Finding the laser position. The blaster should fire a red beam of light at its target. The function for this will be inside a module script so it can be reused in other scripts later on. First, the script will need to find the position where the laser beam should be rendered. Create a module script named LaserRenderer, parented to Starter Player Scripts under Starter Player. Open the script and rename the module table to the name of the script LaserRenderer. Declare a variable named shot_duration with a value of 0.15. This will be the amount of time, in seconds, the laser is visible for. Create a function of LaserRenderer named createLaser with 2 parameters called toolHandle and endPosition. Local LaserRenderer equals the local shot_duration equals 0.15 time that the laser is visible for. Create a laser beam from a start position towards an end position. Function LaserRenderer.createLaser, toolHandle, endPosition. End. Return LaserRenderer. Declare a variable named startPosition and set the position property of toolHandle as its value. This will be the position of the player's laser blaster. Declare a variable named laserDistance and subtract endPosition from startPosition to find the difference between the 2 vectors. Use the magnitude property of this to get the length of the laser beam. Local startPosition equals toolHandle, position. Local laserDistance equals startPosition endPosition, magnitude. Declare a laser C-frame variable to store the position and orientation of the laser beam. The position needs to be the midpoint of the start and end of the beam. Use cframe.lookat to create a new C-frame located at start position and facing towards end position. Multiply this by a new C-frame with a z-axis value of half of negative laser distance to get the midpoint. Local laser C-frame equals cframe.lookat, start position, end position, *cframe.new 0, 0, laser distance 2. Creating the laser part. Now that you know where to create a laser beam, you need to add the beam itself. This can be done easily with a neon part. Declare a variable laser part and assign to it a new part instance. Set the following properties of laser part. Size, vector 3.new, 0.2, 0.2, laser distance. C-frame, laser C-frame. Anchored, true. Can collide, false. Color, color 3. From RGB, 225, 0, 0, a strong red color. Material, enum, material, neon. Parent laser part to workspace. Add the part to the debris service so that it gets removed after the amount of seconds in the shot_duration variable. Local laser part equals instance.new part. Laser part, size equals vector 3.new, 0.2, 0.2, laser distance. Laser part.cf frame equals laser C frame. Laser part, anchored equals true. Laser part.can collide equals false. Laser part, color equals color 3. From RGB, 225, 0, 0. Laser part, material equals enum, material, neon. Laser part, parent equals workspace. Add laser beam to the debris service to be removed and cleaned up. Game, debris, add item, laser part, shot_duration. Now the function to render the laser beam is complete. It can be called by the tool controller. At the top of the tool controller script, declare a variable named laser renderer and require the laser renderer module script located in player scripts. Local laser renderer equals require players.localplayer.playerscripts.laserrenderer. At the bottom of the fire weapon function, call the laser renderer create laser function using the tool handle and hit position as arguments. Laser renderer.create laser, tool, handle, hit position. Test the weapon by clicking the play button. A laser beam should be visible between the weapon and the mouse when the tool is activated. Controlling weapon fire rate. Weapons need a delay between each shot to stop players from dealing too much damage in a short amount of time. This can be controlled by checking if enough time has passed since a player last fired. Declare a variable at the top of the tool controller called fire_rate. This will be the minimum time between each shot. Give it a value of your choosing. This example uses 0.3 seconds. Declare another variable underneath called time of previous shot with a value of 0. This stores the last time the player fired and will be updated with each shot. Local fire_rate equals 0.3. Local time of previous shot equals 0. Create a function called canShootWeapon with no parameters. This function will look at how much time has passed since the previous shot and return true or false. Local function canShootWeapon. End. Inside the function declare a variable named currentTime. Assign to it the result of calling the tick function. This returns how much time has elapsed in seconds since the 1st of January 1970, an arbitrary date widely used to calculate time. Subtract the time of previous shot from current time and return false if the result is smaller than fire_rate, otherwise, return true. Local current time equals tick. If current time of previous shot, fire_rate then. Return false. End. Return true. At the end of the fire weapon function, update time of previous shot each time the weapon is fired using tick. Time of previous shot equals tick. Inside the tool activated function, create an if statement and call canShootWeapon to check if the weapon can be fired. If canShootWeapon, then end. When you test the blaster, you should find that no matter how fast you click, there will always be a short 0.3 seconds delay between each shot. Part 4 Client to Server Communication. Damaging the player. Clients cannot damage other clients directly. The server needs to be responsible for issuing damage when a player is hit. Clients can use a remote event to tell the server that a character has been hit. These should be stored in replicated storage, where they are visible to both client and server. Create a folder in replicated storage named Events. Insert a remote event into the Events folder and name it Damage Character. In Tool Controller, create variables at the start of the script for replicated storage and the Events folder. Local replicated storage equals game, get service replicated storage. Local events folder equals replicated storage, events. Replace the player hit print statement in fire weapon with a line of lure to fire the damage character remote event with the character model variable as an argument. Events folder.damage character, fire server, character model. The server needs to deal damage to the player who has been hit when the event is fired. Insert a script into server script service and name it server laser manager. Declare a variable named laser_damage and set it to 10 or a value as. Create a function named damage character with two parameters called player fired and character to damage. Inside the function, find the character's humanoid and subtract laser_damage from its health. Connect the damage character function to the damage character remote event in the events folder. Local replicated storage equals game, get service replicated storage. Local events folder equals replicated storage, events. Local laser_damage equals 10. Function damage character, player fired, character to damage. Local humanoid equals character to damage, find first child, humanoid. If humanoid then. Remove health from character. Humanoid, health equals laser_damage. End. Connect events to appropriate functions. Events folder.damage character.onServe event, connect damage character. Test the blaster with 2 players by starting a local server. When you shoot the other player, their health will decrease by the number assigned to laser_damage. Rendering other players' laser beams. Currently, the laser beam is created by the client firing the weapon, so only they will be able to see the laser beam. If the laser beam was created on the server, then everyone would be able to see it. However, there would be a small delay between the client shooting the weapon and the server receiving the information about the shot. This would mean the client shooting the weapon would see a delay between when they activate the weapon and when they see the laser beam. The weapon would feel laggy as a result. To solve this issue, every client will create their own laser beams. This means the client shooting the weapon will see the laser beam instantly. Other clients will experience a small delay between when another player shoots and a beam appears. This is the best case scenario. There is no way to communicate one client's laser to other clients any faster. Shooter's client. First, the client needs to tell the server it has fired a laser and provide the end position. Insert a remote event into the events folder in replicated storage and name it laser fired. Locate the fire weapon function in the tool controller script. At the end of the function, fire the laser fired remote event using hit position as an argument. Events folder.laserfired, fire server, hit position. The server now must receive the event that the client has fired and tell all clients the start and end position of the laser beam, so they can also render it. In the server laser manager script, create a function named playerFiredLaser above damaged character with 2 parameters called playerFired and end position. Connect the function to the laser-fired remote event. Local function playerFiredLaser, playerFired, end position. End. Events folder.laserfired.onServe event, connect playerFiredLaser. The server needs the start position of the laser. This could be sent from the client, but it's best to avoid trusting the client where possible. The character's weapon handle position will be the start position, so the server can find it from there. Create a function getPlayerToolHandle above the playerFiredLaser function with a parameter called player. Use the following code to search the player's character for the weapon and return the handle object. Local function getPlayerToolHandle, player. Local weapon equals player, character, find first child of class, tool. If weapon then return weapon, find first child, handle. End. The server can now call fire all clients on the laser-fired remote event to send the information required to render the laser to the clients. This includes the player who fired the laser, so the client for that player does not render the laser twice, the handle of the blaster, which acts as a starting position for the laser, and the end position of the laser. In the player-fired laser function, call the getPlayerToolHandle function with player-fired as an argument and assign the value to a variable named toolHandle. If toolHandle exists, fire the laser-fired event for all clients using player-fired, toolHandle and end position as arguments. Local toolHandle equals getPlayerToolHandle, player-fired. If toolHandle then events folder.laserfired, fire all clients, player-fired, toolHandle, end position. End. Rendering on the clients. Now fire all clients has been called, each client will receive an event from the server to render a laser beam. Each client can reuse the laser renderer module from earlier to render the laser beam using the tool's handle position and end position values sent by the server. The player that fired the laser beam in the first place should ignore this event, otherwise they'll see two lasers. Create a local script in Starter Player Scripts called Client Laser Manager. Inside the script, require the laser renderer module. Create a function named createPlayerLaser with the parameters player_who_shot, toolHandle and end position. Connect the function to the laser-fired remote event in the events folder. In the function, use an if statement to check if player_who_shot does not equal the local player. Inside the if statement, call the createLaser function from the laser renderer module using toolHandle and end position as arguments. Local players equals game, get service players. Local replicated storage equals game, get service replicated storage. Local laser renderer equals require, script, parent, wait for child, laser renderer. Local events folder equals replicated storage, events. Display another player's laser. Local function createPlayerLaser, player_who_shot, toolHandle, end position. If player_who_shot tilde equals players.localPlayer then laser renderer.createLaser, toolHandle, end position. End. Events folder.laserfired.onClientEvent, connect a createPlayerLaser. Test the blaster with two players by starting a local server. Position each client on different sides of your monitor, so you can see both windows at once. When you shoot on one client, you should see the laser on the other client. Sound effects. The shooting sound effect currently only plays on the client that's shooting the projectile. You'll need to move the code to play the sound so that other players will hear it too. In the tool controller script, navigate to the tool activated function and remove the line which plays the activate sound. At the bottom of the createLaser function in Laser Renderer, declare a variable named shooting sound and use the find first child method of toolHandle to check for the activate sound. Use an if statement to check if shooting sound exists. If it does, call its play function. Local shooting sound equals toolHandle, find first child, activate. If shooting sound then shooting sound, play. End. Part 5. Securing remotes using validation. If the server isn't checking data from incoming requests, a hacker can abuse remote functions and events and use them to send fake values to the server. It's important to use server-side validation to prevent this. In its current form, the damage character remote event is very vulnerable to attack. Hackers could use this event to damage any player they want in the game without shooting them. Validation is the process of checking that the values being sent to the server are realistic. In this case, the server will need to check if the distance between the player and the position hit by the laser is within a certain boundary. Raycast between the weapon that fired the laser and the hit position to make sure the shot was possible and didn't go through any walls. Client. The client needs to send the server the position hit by the raycast so it can check the distance is realistic. In Tool Controller, navigate to the line where the damage character remote event is fired in the fire weapon function. Add hit position as an argument. Events folder. Damage character, fire server, character model, hit position. Server. The client is now sending an extra parameter through the damage character remote event, so the server laser manager needs to be adjusted to accept it. In the server laser manager script, add a hit position parameter to the damage character function. Function damage character, player fired, character to damage, hit position. Below the get player tool handle function, create a function named isHitValid with 3 parameters, player fired, character to damage, and hit position. Local function isHitValid, player fired, character to damage, hit position. End. The first check will be the distance between the hit position and the character hit. Declare a variable named max_hit_proximity at the top of the script and assign it a value of 10. This will be the maximum distance allowed between the hit and character. A tolerance is needed because the character may have moved slightly since the client fired the event. Local max_hit_proximity equals 10. In the isHitValid function, calculate the distance between the character and the hit position. If the distance is larger than max_hit_proximity, then return false. Local character hit proximity equals character to damage. Humanoid root part, position hit position, magnitude. If character hit proximity, max_hit_proximity, then return false. End. The second check will involve a raycast between the weapon fired and the hit position. If the raycast returns an object that isn't the character, you can assume the shot wasn't valid since something was blocking the shot. Copy the code below to perform this check. Return true at the end of the function. If it reaches the end, all checks have passed. Local tool handle equals get player tool handle, player fired. If tool handle, then local ray length equals hit position tool handle, position, magnitude. Local ray direction equals hit position tool handle, position, unit. Local raycastparams equals raycastparams.new. Raycastparams.filter descendants instances equals the player fired, character O. Local ray result equals workspace, raycast, tool handle, position, ray direction * ray length, raycastparams. If an instance was hit that was not the character, then ignore the shot. If rayResult and not rayResult, instance, is descendant of character to damage, then return false. End. End. Return true. Declare a variable in the damage character function called validShot. Assign to it the result of a call to the isHitValid function with 3 arguments, player fired, character to damage, and hit position. In the below if statement, add an operator to check if validShot is true. Local validShot equals isHitValid, player fired, character to damage, hit position. If humanoid and validShot, then now the damage character remote event is more secure and will prevent most players from abusing it. Note that some malicious players will often find ways around validation. Keeping remote events secure is a continuous effort. Your laser blaster is now complete, with a basic hit detection system using raycasting. Try the Detecting Player Input course to find out how you can add a reloading action to your laser blaster, or create a fun game map and try your laser blaster out with other players. Final Code Tool Controller. Final Code Laser Renderer. Final Code Server Laser Manager. Final Code Client Laser Manager. We will be sharing more video and Roblox tutorials, and then you will be able to make your own games on Roblox for fun and profit. Also share this video with your friends. Subscribe to channel and like the video. Till next time, stay safe and follow us for more upcoming tutorials.